Hey, how's it going? Hope it's going well. In this section we're going to look at animation. So effectively like a flip book. We flick through a series of images to make a character look like it's walking, jumping, falling over, whatever. It's a really useful way of getting quite complex things to happen on screen and to make it look really dynamic. Hey, let's get started. This is the sprite sheet we're going to be using throughout this section, and you can see it's got a series of images of a cartoon bucket. If we look at this, I've set the update at extremely slow, and you can see that it's moving through a cycle of images that gives the impression that the bucket is walking. Let's speed up the motion and look at that again. So there we have a bucket walking across the screen. When it gets to the right hand side, it resets itself to the left, walks through again. So that's what we're going to be doing in this video. The first change is to our states object. We're setting a series of frames. So we have a state called walk. That's the only state we've got. That's got a series of frames. These indices refer to the index into the JSON file. So that will be frame 0, frame 1, 2, 3, 4, 5, 6 and frame 7. We set loop to true, so when it gets to frame 7 and it's finished displaying it, it will jump back to frame 0. And we also have a motion property where X is set to 120, that's the number of pixels the sprite is going to travel in a second, and Y is set to 0, so it's just going to go in a horizontal line. And we set frames per second to 8. It's quite a low value, that, but cartoons can just about stand it. So let's have a look at any other amends. We've got an amendment to our spawn section where we don't pass in a frame. Instead we pass in the entire JSON file that we downloaded, which we stored in the game object as this.sprite data. And we just keep an easy reference to the bucket, which we'll use later. We're not going to do any more spawning. That'll be the only one that gets spawned. If you notice in the update, we've taken out all the spawning if time has exceeded a certain limit. So the Sprite Constructor has got some amends. We've got the width and height back, and we've got the JSON being stored in there. We also calculate the duration of the current state. It's based on the number of frames in the frame array and the speed of the frame updates. So that'll set the duration of this current state walk. We've introduced a new getter for offset. Now this is quite an interesting one, and let's look at a diagram to try and explain it. When we export the frames, they're all in relation to a source size. So they all have exactly the same source size. That ensures that the image is anchored within this rectangle. But once we've pasted it into our sprite sheet, we have a rectangle like this, like the blue rectangle here. So we need to be able to calculate from our anchor point here to this point here, which is going to be the draw location. And there's various things that we need to take into consideration. One is the source size, the other is the frame size, the other is the anchor, and finally the scale. So we take the source size width, which is going to be common for all our images in this bucket. we subtract the sprite source size .x, that's this position here in relation to this box. So the position of the top left hand corner of the blue frame in relation to the source size yellow box. And then we multiply that by scale and by the anchor in the X and the Y. That gets us from the anchor position to there, calculates that position both in the X value and in the Y value. So we'll be using that in our render method. Our update method is completely changed. This has now got current time being incremented by delta time. That's the time that's elapsed since the last time we did a frame refresh. And we check whether or not that has exceeded the duration of the current state we're in, which we remember we calculated at the very beginning here. If the state's looping, then we decrement the current time by the duration of the state. That will cause the loops to cycle round. And then we add the current state motion multiplied by delta time, so things are in relation to seconds, to both the X and the Y value. If the X value is over 500, then the bucket's going to be off screen to the right, in which case we reset it to -100, which is off screen to the left. Now we need to find out what image it should be currently showing. To do this, we divide the current time by the state duration. That will give us a number between 0 and 1. And we multiply that by the number of frames in our state frames array. So that gives us an index into the state frames array. So we look into the state frames array based on this index. That's what that's doing. That will pull out whatever the current frame is in that. And that is the frame we get from our JSON file. And we store that in our frame data property for the sprite. We use all that in our render so that we take the current frame from the frame data we calculated here, and we get the offset, which recall is this function here, which we looked at the diagram about. And we use all this to work out where in the source we should be taking our image from and where in the destination we should be painting it to. And that gives us a walking bucket. This video is from my Udemy course, HTML5 Game Development Beginner to Pro. To get the full course at a great discount, pull down the description.